Now this is something different, okay? Now this question also I want you to rework, okay? This is a parallel bar, okay? It's a parallel bar, okay? Previously, whatever we have done, we considered as a series bar. Now, a composite block dimension in millimeter shown in the figure below. Find A, the value of A. That means the thickness of this and the thickness of this here. So find the value of A, okay? Find the value of A if the portion of the load carried by the aluminum plates. Now this is a hint given here, so you have to take note, okay? Excuse me. The load carried by the aluminum plates is half the portion of the load carried by the copper core. So this is the copper core. These are the aluminum plates, okay? So part B, find the total load if the stress in the copper is 90 megapascal. If the stress in the copper is 90, okay? So we know that based on the first, okay, assumption, for parallel bars, usually we consider that the deformations. So usually previously we use X, right? Here I use delta, sorry. Because the symbols doesn't matter. The most important thing is you must know this symbol here stands for what, okay? So this is deformation. That means usually we have used it as X, okay? XA equals to XC. So what is A and C? A is for aluminium, C is for copper, okay? These are the two conditions that we have. These are the two conditions that we have for parallel bar. One, the deformation of the materials for both materials must be the same. Second, the total load must be equals to the sum of the loads absorbed by the different materials. So that means PA plus PC. So, and we know that deformation is FL over AE. F, P or F, because certain books they use P, certain books they use F. Certain books they use X, and certain books they use delta, okay? Or certain books they use delta L, okay? This all refers to deformation. If it is denoted as delta L, that means the change in length. So if it puts a delta only, so that means it refers to only the deformation or the changes in length for aluminium and the changes in length for the copper material. And we know that both deformation is given by the formula FL over AE, that is based on the definition of stress and the definition of Young's modulus. You will arrive to this and this formula. So changing the PA and the PC to be the subject, you see here, changing PA and PC to be subject. Because why we are taking P to be the subject, why the force or the load to be the subject? You can see there is a section at B here. They say the load carried by the aluminum plate is half the portion of the load carried by the copper. This is the hints that is given in the question. So you must refer to the hints that is given in the question. So that is why I am taking the force or the load to be the subject in this case. That means from this formula, manipulating this, changing this to be the subject, so you have this. Taking PC to be the subject, manipulating this, you have this. Okay? Now, since the load carried by the aluminum plates is half the portion of the load carried by the copper core. So this is the copper, these are the aluminium plates. So you can write here PA is equals to half PC. Half, can you see? The question they have given you, half. Okay? So you can say PA equals to half PC, or you can say PC, bring this 2 over, will be PC equals to 2 PA. So we can refer to this condition here for parallel bar, okay? So that is here. So replacing PC here with 2 PA. Okay. So you got to know that PT now is equals to 3 PA, and PA is equals to this here. So PA. So this will give you the total load. Okay, this is the total load. So we know that total load is PA plus PC. So this part here plus this part here. So that means this, okay, this plus this, place it here and here. Can see? So and then we know that area is equals to 70A squared. How you got this area equals to 70A squared? So aluminium area. So 70 times A. Okay, 70 times A. Okay, 70 times A, the area of aluminium. Why is this square? Okay, and then the area of C for copper, 70. That means this is 70 times 30. 70 times 30. 70A squared. 70 times A, you got 70A. So, but then you need to times with 2. So I think it's 2 times 70A, it's not 70A squared. Okay, so you all better take note of this. Okay, 70A squared, A, 70 times A, so it is 70A. Okay, so once you got this area, so you put it here. Don't look at this first. Don't look at this first. So everything in terms of A, yeah. Once you have everything in terms of A, so you see your PT, your EA, AA, EC, AC, okay? Delta is the same, right? Delta for both the material is the same. So you can extract your delta, and then the length, original length for both is the same, 300, okay? So that is why you can extract this, and this one here out from here, from this. So you got this, okay? And we know that PT is what? PT earlier we got it is equals to this, so we have this, okay? So we have this whole equation here. So the length can cancel off here. The delta can cancel off. Can you see? Delta A and delta is all the same, the deformation. Again, the length and the length of the total length, the length of all the materials are the same. So that means this and this is the same, this and this is the same. So you can just strike it off. So you have this equals to this. Okay. So now we know that ECAC is equals to twice of EAAA. Okay. Let me see what it is. Okay, so from here, okay, so from here you have, okay, bring this over, okay, this equation here, bring it over, 3EAAA, bring this thing here over, so you have 3 minus this, so you have 2, okay, so equals to this one, bring it over, so 3 minus 1, so you have 2, okay, so you have ECAC, so from this equation you have AA, which is equals to this. Now we know that AA, I don't think so, is A square, okay? Because we know that the cross section, because this is a force, so the area, one area here, the area of one plate is 70 times A. The area of two plates should be 2 times 70 times A. Okay, so you must have 70 times A plus 70 times A, not 70A square, yeah? A mistake here. Okay, a problem here, mistake here. Everyone please redo, yeah? Okay, so you have to find out the A. So, and then the total load, we know that PA plus PC and PA is equal to half PC. So you get 3 over 2 PC. And we know that PC is equal to sigma C times AC. So this is a formula, okay? Because from the stress definition, stress is equal to force over area. So the subject PC, that means the subject force, then you have stress times area. So just put in your stress, put in your area, so you can find out the total force. Now the only problem is this one. Okay, so you all double check with us. Okay, double check. Okay, so the area for aluminium should be 70 times A plus another 70 times A. So it must be, okay, 70 times A plus 70 times A. Yeah? Okay, that's for this example. That is for the class for today. Okay, thank you for attending my virtual class. Okay, thank you.